Today we're going to talk about sales and operations planning. However, I want to start with ABC analysis first. Somebody asked me about ABC analysis from the previous week, and I wanted to talk about it in class because everybody should know how to do an ABC analysis. So let me start with ABC analysis. Okay, so ABC analysis is a system for ranking inventories. However, the idea is so general, you can use it in many applications. So the idea is, let's find the most important inventories. Those are called A items. And then there is less important items, B items, and then there is least important C items. And depending on how important an SKU is and an item is, you will have to follow different management policies. Okay? So how do you know which items are the most important items? Okay? So the most important SKUs, products or services that you sell, are those that generate the most revenue or profit. Okay? So you may have hundreds of SKUs, many different services, but some of them will generate most of the revenue. And this is also called the Pareto's rule or 80-20 rule. What this means is that a small portion of your products and services will generate a large portion of your revenues and profits. Okay? So if you think about this in terms of customers, you may have hundreds or thousands of customers, but this rule says 20% of your customers will generate 80% of your sales. Okay? So they are few in number, but they account for the majority of your revenues or profits. Similarly, if you look at your products or services, a small percentage of your services will generate most of your revenues and or profits. And you can apply this idea to many different situations. Okay? So what does this look like? So here's an example. These are the SKUs. So we're starting with the best-selling SKUs, rank the SKUs from the fastest selling to the slowest selling SKUs. And this is how much revenue these items generate. Okay? So starting with the best-selling items, the best-selling 5%, okay, in this case, generates 70% of the revenue. Okay? And then the next best-selling 10% of items generate an additional 20%, and the rest, okay, so that's 5 plus 10, the remaining 85% generate only 10% of the revenue. So this is an example. These percentages may change. However, the idea is your most important item, best-selling items, biggest customers, etc., a small percentage of them will generate a huge or big portion of your revenue. Okay? So if we're talking about this in terms of inventory management, okay, so let's say your A items generate 70%, B items generate 20%, C items generate 10% of your revenue. Okay, you want to have different policies for them. You need to manage them differently. Because if you run out of stock on a C item versus an A item, okay, a C item will have much weaker consequences. It's not that important if you run out of a C item, but if you run out of an A item, your revenues will suffer a huge hit, okay? So what you do in this particular case is you want to be in stock on A items most of the time, and your customer service level would be 98%. You'll have much more inventory so that you will be in stock 98% of time, and you will run out of stock only 2% of time. Now, B items are less important because they generate 20% of your revenues. And then the idea is you don't have to carry as much inventory. You can carry a little bit less inventory so that you're in stock 90% of time and you run out of stock 10% of time. And the C items only generate 10% of your revenue, okay? And you might say, again, these numbers are examples, and you might say, okay, maybe 85% is good enough, so you keep less inventory because they're less critical to your operations and revenues. Now, let me give you an example of this, and how do you do this in Excel, okay? So, on Blackboard, I have uploaded a sample data file, 2013 retail sales by town, all towns in Connecticut, okay? So you can download this file, and it looks like this. And let me just, okay. So the first column gives you the name of municipality, Andover, Ansonia, Ashford, Avon, etc. Okay, and column B is number of taxpayers, total sales of retail goods, okay, taxes, various columns. Okay, for this example, I'm going to get rid of these. I'm going to delete, just to make things simpler. And let me format this with number. All right. So these are municipalities starting from 001, 002, 3, 4, 5, etc. And the municipalities go all the way to 169. Okay. So for ABC analysis, we first need to sort these from the highest to the lowest sales tax. Okay. So what I'm going to do is I'm going to custom sort total retail sales from largest, okay, total retail sales, largest to smallest. Okay. So then I have this. Okay. So this is the municipality with the highest retail sales, second highest, third highest, etc. And now what I'm to do is I need to find the cumulative sales. Okay. So for that, the equation is the sales plus the previous cumulative. Okay. So I copy this. Okay. So this number here, so the first one equals the first one, but then here, this is the sum of 1 and 2. The third entry here is the sum of the first 3, sum of the first 4. Okay. So these are cumulative sales, And what we can do is we can click, select the cumulative sales, and we can draw a line chart. Okay? So the line chart looks like this. Let me modify this a little bit. So here we have, we're starting from 1, 2, 3, 4, 5. So these are the entries, the first entry, 6, 7, and we go all the way up to 169. And this is the cumulative total sales. Okay? So we can see a pattern, but we don't have the percentages. Okay? So how do we do the percentages? To convert this to percentages, okay, we do this. So here, so this is the last municipality, and I calculate the sum of all municipalities. So this is going to be sum of everything. This is the sum, okay? And then the percentage here will be equals this particular cumulative divided by this here, okay? So this comes out to be, let's do this 7%, okay? So I'm going to put a dollar sign here because I want to keep this constant, and this is the cumulative. Okay? So I copy this. Okay? So the highest selling municipality accounts for 7% of the total sales. The first two, 1 and 2, account for 13%. Let me magnify this. Okay, so the first municipality accounts for 7%. The first two account for 13. The first 3 account for 19, etc. It grows like this, and so I can select this, and I can go to insert line graph. Okay. So as you can see, so this is 100%. If we look at which ones are A, B, and C municipalities, right? So let's look at that. So I'm just looking at this. So if this is, let me change the format the axis here. Format axis, major 2, 1. Let's do this. 1. Okay, and okay, so let's say 70%. Okay, so 70%. Let's look at. So the first 29 municipalities account for 70%. Okay, and then let's look at 90%. Okay. The first 64 account for 90%, and the remaining, so this is 169, so this is 105, okay? The least selling 105 municipalities account for 10%, okay? 10%. Okay. 10%, okay? So this is 29 to 64, that's gonna be 34, 35 here, 35. These counties or municipalities account for, I would say, 20%. and the first 29 account for 70%. Okay? So this is one way of analyzing this. Of course, these are not cast in concrete. You can just play with them depending on your data. But you can say, okay, the most important portion, 70% of total sales, comes from the highest selling, most selling 29 municipalities. So these will be your A municipalities or A items, or you can, and then you'll have B municipalities, C municipalities, and then if you just didn't tax any of these counties, you would only lose 10% of your revenues, okay? So these are the most important municipalities. So one thing you can additionally do is you can turn these into percentages, okay? So what percent of counties account for, let's say, 70% of total sales, okay? For that, let's change this a little bit, okay? So here, this is municipality 1, municipality 2, etc. Okay. So all the way here. So this is municipality. It's just basically the number. And what is the percentage of this? So this divided by 169. Okay. So let's turn this into percentage. Let's increase the decimal point. So it's a 0.59 of counties accounts for this 7% of sales. 1.18 accounts for this much, etc. And then I can draw a scatter plot, okay? So this is going to be here, and then insert scatter plot. Where is this? Here, okay? So select data, okay? And then series edit. The X values will be these percentages. X values will be these percentages. Okay. All right. So, okay. All right. So, and then let me format the axes a little bit. So this is going to be 0.1. Format this axis. Say 0.1. Okay. So anyway, so this let's see again. So again looking back at the previous categorization. So this is 20%. So in this case, 20% of municipalities accounts for 70%, okay? They generate 70% of sales. From 20 so this is 50, this is 40, I'll say 25%, maybe, 25%, so, no, 35, right? 25% generate additional 20%, okay? And the remaining, this is going to be 55%, generate 10%, okay? So this is how you identify your most important A items, B items, and then C items, okay? So now, this is how you do ABC analysis. let's turn to our topic for today, sales and operations. Okay, so today I want to discuss sales and operations planning. And the idea here is we're moving from forecasting to decision making. Okay, so far we have discussed how to generate high quality forecasts, and now we're moving to decision making. Okay, so our focus is what decisions do we have to make, okay, and then how those decisions will be supported by forecasts. Okay, so the first topic is sales and operations planning. So what is the challenge here? Why is this a problem? Now, if you think about it, in a company, every department needs a forecast. Okay, so every department needs to make a plan for the future, and every department needs a forecast. So, and typically, what happens is that every department will have a forecast of its own, and none of the forecasts will agree with each other. Okay, so marketing will have a forecast, and that's not going to agree with the finances forecast. Finances forecast will not agree with operations forecast, logistics forecast, etc. Now the question is this a problem for a manager? Now imagine you are a manager and you're in charge of all of these departments. You're managing these departments. You're the CEO. Okay, all of these departments report to you, and they happen to have different expectations from the future. They have different forecasts. Now, is this a problem for you who manages all these departments? The answer is yes and no. Okay, because sometimes you can manage a company where each department has a different forecast. Okay, that's possible. But sometimes you want to run your company where every department has the same forecast. They share one common number. Okay, so then if you want to have an agreement between all these functions, how do you reconcile these forecasts? Okay, so everybody thinks their forecast is the best, and everybody thinks everyone else's forecast is crap. So how do you get them to talk to each other and agree on a single forecast? Okay, or if you want to skip that, how can you have them work together effectively and efficiently without agreeing on a single number? Okay, so that's the question of today. So now, first of all, if the company has historical sales, and if all departments look at the same time series data, how come they can have different forecasts? And the reason for that is different departments have different incentive structures. Okay, for some departments, it's better to under forecast. For other departments, it's better to over forecast, and so on and so forth. Okay, so the idea is every department has a different goal with the forecast. Okay, so that's why they start with the same numbers and they end up with different forecasts. So to reconcile different forecasts of different departments, people have developed a process called sales and operations planning. okay? So this is a process for integrating different forecasts, and the goal is to balance supply and demand, okay? So there are all these forecasts floating around, and none of them agree with each other, and we're going to make decisions based on these conflicting forecasts. How can we balance supply and demand? Obviously you can't, okay? So you need to follow this sales and operations planning process where you generate a consensus forecast, and this consensus forecast should be such that it balances supply and demand, how much you can produce and how much you can sell, okay? So the consensus forecast is supposed to balance production and sales. So now what happens if you don't have a common forecast that all departments agree, okay? So these are some quotes. I'm not going to go over them one by one, but some typical examples are, so manufacturing says sales are highly overstated, so that means salespeople artificially inflate the forecasts for production, okay? And manufacturing department says we will figure out what to decrease. So the manufacturing department unilaterally decides how to decrease forecasts, okay? They don't trust forecasts coming from sales. And here, sales, marketing says, okay, there's a new promotion we need to do next week, okay? So they decide on the promotion on their own without consulting other departments, okay? So here's another example, the sales. So the sales force gets a customer order, okay? And they need to enter it into the system so that manufacturing produces that order. But they know manufacturing will unilaterally cancel some orders because they're going to decrease the forecast. But what they do is they take a single order and they enter multiple duplicate orders into the system because they know manufacturing will cancel some of them unilaterally without asking them. So as soon as the manufacturing produces one of these duplicate orders, they'll automatically delete other orders. So as you can see, there can be a mess when different departments work off of different numbers. So independent planning can lead to strategic misalignment, okay? What we mean by independent planning here is when every department has their own forecast and their own plan independent of other departments, then there can be a misalignment, okay? They don't work towards the same goal. Every department will have a slightly different objective, and you can have a misalignment. Then, if something goes wrong in satisfying customer demand, everybody can blame everyone else. Okay, if something goes wrong, it's never our department, it's never our forecast, it's never our plan, it's always other departments, other forecasts, other plans, okay? And as a result, there can be a big difference between your plans, budgets, and actual results because of the misalignment, okay? So, customer service level may suffer because of this, or cost of servicing customers may increase Okay, capacity utilization, all these things can happen. In addition, especially when you launch new products, they can miss their launch dates because of the misalignment, because every department works off of a different plan, off of a different forecast. So new product launches may miss their launch dates. Product phase-outs, okay? So these are product phase-outs. So this is a product that you don't want to produce anymore. You want to phase out the product. That can be problematic. And there can be SKU proliferation. SKU proliferation. What is SKU proliferation? Let me show you a video about SKU proliferation. So let's go to.
What is this? That's cheese. What is this? That's cheese. And this, what is this? Cheese also. And what is this one? That's cheese. This one over here, what is it? Cheese. And this? That's cheese. And this? Cheese. And this? Cheese. And what is this? Is it coffee? Is this a rice? That's cheese also. And this is a rice? That's cheese also. And what is this? That's cheese. And what is this? That's cheese. And what is this? Cheese also. And this one here is a rice? That's cheese. And this is? Cheese. And what is this? That's cheese. And what is this? What is this? That's cheese. And what is this? Cheese.
So,
And what is this? That's cheese. And what is this? That's cheese. And what is this? That's cheese.
so you can watch the rest of the video. So this is what SKU proliferation means. So companies like new products, they like to introduce new products because new products are more profitable than older products. But as they keep introducing new products, the product portfolio just grows and grows and grows, okay? So that is called SKU proliferation. And SKUs, the product portfolio has to be pruned from time to time by phasing out less well-performing SKUs. Okay. So this is a simple representation of the sales and operations planning process. Now this process is repeated every month. Every firm implements this slightly differently, but in most cases, this is repeated monthly, okay? So they complete 1 month cycle and then they start over again, and etc. So in step 1, the marketing department comes up with the unconstrained forecast, okay? So they look at new products, brand, market shares, etc. The idea is how much can we sell if we had no constraints, no limitations. So this is the best case scenario. This is how much potentially a company could sell. Okay, so this is step 1. In step 2, operations, okay, comes up with the constrained forecast. Okay, constrained forecast means given our limitations, given our limited resources, our limited capital, our limited labor, limited technology, etc., what is the most we could produce? What is the most we could sell? What is the most we could produce? Okay. Typically, those two forecasts will not agree with each other. Okay? So then the question is, how can we reconcile these two numbers? Okay? So one may be high, one may be low. Which one is more realistic? What should we do to reconcile? Should we increase production? Should we raise prices or whatever? So you need to think about how to reconcile these two conflicting forecasts. And that comes under the balanced plan. Okay? So sales department and operations department work together to come up with a consensus forecast on which they can both agree. So how can we reconcile these two conflicting forecasts? They come up with a balanced plan. Now, this balanced plan will have financial implications. Okay, so how is this going to affect our revenues, profits, customer loyalty, all these things? So the finance department reviews the balanced plan and identifies financial implications. Now, the balanced plan and the financial review goes to high-level executives. So these are the decision makers, okay? Sales department cannot overrule operations, operations department cannot overrule sales, but at the end of the day, these decisions, the final decisions, are made by senior executives, and once they approve the plan, you have the one consensus forecast, single number forecast, okay? And they implement the plan, and the following month, they start all over again. Okay, so this is a monthly process that goes on. Some companies do this in shorter intervals, some companies do this in longer intervals, but overall this is a monthly cycle. Okay. So the sales and operations plan looks at the aggregate level, aggregate sales, total sales. So when we're talking about constraint forecast, unconstrained forecast, we're talking about total sales, not individual SKUs, okay? Or sometimes it's product lines, okay? So we're talking about aggregate demand, and every month you look into the next 12 to 24 months, a year and a half, but not more than 2 years, because this is tactical level planning. Strategic level is 2 or more years. Operation planning is daily, weekly, and tactical planning is multiple months or multiple quarters, okay? And that changes from company to company. So these meetings are standardized because they are repeated over time. So there has to be structure, and everybody should know what everybody else is doing. And they need to follow a certain plan. They're repeatable. And the most important thing is you should have cross-functional participation. Okay, why is this? First of all, what is cross-functional participation? All the different departments have to participate in this. So every department should bring in their input to the table, and at the end of the sales and operations process, everybody should accept the consensus forecast and the consensus plan. Okay? So the idea is, let's get everybody around the table and let's come up with a solution that everybody accepts. Okay? So, okay. So, now the output from the sales and operations plan is the one plan, the consensus forecast. Now, given this aggregate high-level forecast, there will be two plans, production plan and demand plan. What does this mean? So, in order to reach these goals, in order to implement this plan, okay, this is what production needs to do, and this is what marketing needs to do. This is the marching orders for production. These are the marching orders for marketing, okay? So they have agreed on this plan. This is their common goal. And production and sales or marketing, they have their own plans. This is what marketing needs to do to achieve this. This is what production needs to do to achieve this. So once SNOP is over, the production demand, the production department needs to make an aggregate production plan, okay? And the aggregate production plan looks like this, okay? So let's say these are the months of January, February, March, April, all the way to June. And these are the forecasts, okay? Now, where do the forecasts come from? These come from sales and operations plan, okay? So marketing and operations have both agreed on these numbers, okay? Now, production needs to decide how much to produce in each month, okay? Aggregate production plan is, so plan means schedule. Production plan means you need to schedule your production levels, okay? So how much to produce in January, how much to produce in February, how much to produce in March, etc. Okay, this is the plan that production needs to make. So at the end of 6 months, there's a total demand of 240,000. And to balance supply and demand, you should also produce 240,000 over 6 months. Okay? So think about how much should be produced every month. Okay? Okay, what is the best way? What is the best schedule of production such that at the end of 6 months, you produce as much as demand? Okay. I'll give you a few seconds. Think about it. How much to produce every month? So, one simple idea is, if we need to produce 240,000 units over 6 months, maybe we should produce 1/6 every month. So if you produce 40,000 every month, so 40,000, 40,000, 40,000, 40,000, 40,000, 40,000. So 6 times 40,000, 240,000 production, okay? And supply equals demand. Okay. Now, is this a good way? Is this the best way? Is this the best schedule? Is this the best plan? Okay. So, one advantage of this is, as a manager, this production plan is very easy to manage. Okay. Why? Because you make the same amount of product every month. Now, demand increases or decreases, but you don't care. okay? This production plan will give you 240,000 items every over 6 months, and you will meet total demand. It's very easy to manage because you don't worry what happens with the demand. Okay, so the advantage of this is that it's easy to manage. But is there also a downside to this? Okay, is there a downside to this? So let's see what happens in month 1. So in month 1, January, the customers want 24,000 items, but you make 40,000 items. Okay, you cannot sell 40,000 items because you cannot force your products on your customers. So the customers only buy 24,000. So what happens with the excess production? So the excess production has to go to your warehouse. So that's going to be 16,000 items put in inventory. Okay? So in January you make 40,000 items, you sell 24,000 items, and the remaining 16,000 go into inventory. Okay? So at the beginning of February, you already have 16,000 items. Plus, you make 40,000 items, because that's what you do every month. But customers only want 32,000 products. Okay? So again, you cannot sell your production. You have produced more than demand. And so you sell 32,000 items, and the remaining 8,000 will be added to your inventory. So this is going to be 24,000. Your inventories will increase. So at the end of February, you will have 24,000 items in stock, and you're going to begin the month of March with so much inventory, okay? And on top of that, you're going to produce 40,000 more items, okay? But again, the customers don't want as many products. So what do? So you sell 32,000 items to your customers, and the remaining 8,000 goes to your inventory. So your inventory increases to 32,000. Okay? So now you have 32,000 items in your warehouse. So you begin April with that much inventory, okay? Plus you produce 40,000 items like every month, okay? But then look at the demand. Demand spikes, okay? So customers demand more than 40,000. So that's good because you can sell everything you make, and customers will still want 8,000 more. Okay, so you get that 8,000 from your items in the warehouse. Your inventories will decrease by 8,000. So your inventories will drop to 24,000. Okay. So you begin May with 24,000 items in your warehouse, and then you're going to produce 40,000 items. Now demand is 60,000. Okay, so you sell everything that you make, but customers want 20,000 more. You look at your inventories. Yes, you have more than 20,000 in inventory. So this 20,000 extra demand comes from your warehouse. Your inventories drop to 4,000. Okay. So at the beginning of June, you have 4,000 in inventory. You make 40,000 items in June. and demand is 44,000. So you sell everything that you make, 40,000, and you sell 4,000 items in your inventory, and you end up with 0 inventory. Okay? So this strategy is called level strategy because the production level is constant. As demand increases or decreases, you keep more or less inventory. Okay, so the idea is this is very easy to manage, but you will have to have a warehouse and you will carry extra inventory. Okay, this is the level strategy. So what do you do if you don't want to carry any inventory? Okay, so the idea is carrying inventory is costly. Okay, so you don't want to carry any inventory, but then if you produce the same amount every month, you'll have to carry inventory. So what do? Can there be a different production schedule, a different production plan, where you have 0 inventories, 0, 0, 0, 0, 0, 0. Okay. Well, this is called chase strategy. In chase strategy, you produce only as much as customers demand. So in January, customers demand 24,000 items, so you only produce 24,000. Okay, you produce 24,000, you sell 24,000, you end up with 0 inventory. In February, customers want 32,000, so you produce 32,000, and you sell everything that you produce, and you end up with 0 inventory. Similarly, March, 32,000, okay, 0 inventory. April, 48,000, 0 inventory. May, 60,000, 0 inventory, and then 44,000, 0 inventory. Okay, so this is called chase strategy because production chases demand. As demand increases, production increases. As demand decreases, production decreases. And you don't have to carry any inventory. You just end up with 0 inventory at the end of the month. Okay? So the advantage is you carry no inventory, but the disadvantage is you need to increase or decrease production. And there are costs associated with it. So for example, when you go from 24,000 to 32,000, okay, you need to produce 8,000 more items. Okay? So that means you need to buy extra equipment. You need to buy extra supplies. You need to hire extra workers, and there are costs associated with those. Here, from 32 to 32, there is no extra production. But here again, you go from 32 to 48,000. Okay, you need to buy extra inventory. I'm sorry, not extra inventory, extra machinery, technology, supplies, hire additional people, have your workers work overtime. So there's a cost of going from 32,000 to 48,000. Here, you go from 48,000 to 60,000. Again, additional cost of hiring workers, buying equipment, etc. Here, you go from 60,000 to 44,000. Okay, so you have a lot of equipment, you have a lot of workers. Here, you need to reduce production. How do you do that? you lay off workers and you sell extra equipment. Okay? So there's also a cost associated with decreasing decreasing production. You decrease your capacity by 16 units. So decreasing capacity means you need to lay off workers, and then you need to sell your extra equipment. Okay? So again, the advantage is you have zero inventories. However, you need to increase or decrease capacity all the time. So every month demand will change, every month production will also change, and every month you need to either increase capacity or decrease capacity. Okay? So these are the two basic strategies. Okay? So aggregate production plan is a schedule of production where you want to meet demand. So supply and demand must be balanced. Okay? We are at this point, we're only talking about finished goods inventories. Okay? We're not talking about work in process inventories. We're not talking about raw material inventories. These are all finished goods inventories. Okay? So because we're at the high level. And again, we're talking about total production. Okay? So if you look at this is the total production. All SKUs combined. We're not talking about individual SKUs. Okay? So this is all SKUs combine so many products. So this is the level strategy. Okay, this is the chase strategy. Now, which one is better? Okay. Both of them give you 240,000 items of production, but which one is better? That depends on which one is least costly. Okay, so there's a trade-off. On the one hand, the chase strategy has no inventory costs, but it has costs of increasing or decreasing production. Level strategy has no costs for increasing or decreasing production, but it has inventory costs. Okay? Now, what you want to do is you want to find the strategy that gives you the lowest total cost. Okay? What is the lowest total cost? Now, total cost has a number of components. Okay? First, there is the cost of regular production, okay, during the 8 hours of working day. The cost of regular production. If that's not enough, you will have to pay your workers overtime. Now, the labor rates of overtime are 50% greater than regular time. So if you pay your workers, let's say, $50 an hour for regular production, overtime will be $75 an hour, okay? 50% more. There's the cost of increasing capacity, there's the cost of decreasing capacity, there's the cost of subcontracting. Now this means that your regular production is not enough. When you do overtime, still not enough. Whatever you cannot produce during regular and overtime, you outsource your manufacturing to a contract manufacturer. Basically, you're subcontracting. Plus, there is inventory carrying cost, plus cost of backlog, or lost sales. Okay? So this is, the sum gives you the total cost, and you will try different strategies and calculate the total cost, and you want to find the strategy that gives you the lowest total cost. Now, level strategy and chase strategy are not your only options. You can have a mixture of both. You can have hybrid strategies. Okay, how does this work? So a hybrid strategy looks like this, where, so this red triangle is the production. So some of the time you are using a constant production level. This is level strategy. And then you adjust your production level and maintain the same level for some other time. And then adjust again constant level. Okay? Sometimes a hybrid strategy is better than a level or a chase strategy, depending on your costs. So for assignment 5, I'll ask you to do an aggregate production plan. Okay, the Excel file is over here, and you need to submit it by March 18. And the aggregate production plan looks like this. Okay, so let me magnify this a little bit. So these are the forecasts. They come from SNOP, Sales and Operations Plan. And these are the months from January to December. And we need to decide how much to produce during regular time, how much to produce during overtime, how much to outsource. Okay? So if we add regular time production, overtime production, outsource production, we will have the total supply, and total supply must equal total demand. Okay? In addition, we have the cost of increasing production, decreasing production, we have excess inventories, and then we have backlog. Backlog means we cannot meet customer demand, so we put the customer in a waiting line. There's backlog, and there's a cost associated with it. So here, the regular production costs $1 per item. Overtime costs $1.50. If we subcontract manufacturing, every item costs $2. The cost of increasing capacity is $2 per item. The cost of decreasing capacity is $1 per item. The cost of holding inventory is $1 per item. And the cost of backlog is $2 per item. Okay? So let's try the level production. Okay? So level production means we're going to have a constant production level over 12 months. We're not going to use overtime or subcontracting. Okay? And we're not going to increase or decrease production. We can have sometimes extra inventory, and when inventory is not enough, we can have backlog. Okay? So how much should we produce every month? So calculator. So 5,903 divided by 12. Okay? It says 492 items every month. 492. Okay, so let's do that. 492, and then, okay. So if we produce 492 items every month, the same number, this is the total supply, okay, total supply. This is the total demand. Because of the rounding error, we produce one more item, so that's easy to fix. So I'm going to come to December. I'm going to produce 491. Okay, so if I produce 491, I'll have exactly the same the same supply as demand. Okay, so this production plan is feasible because it meets total demand. Total supply meets total demand. Okay, so no overtime, and then under this plan, I never increase production. I never decrease production except for this. It's just, you know, because I go from 492 to 491, so you could basically ignore this. I don't have excess inventory, but I have some backlog, okay? So what is my total cost going to be? So I'm going to have the cost of production, okay? And then the cost of backlog, okay? And here, if you scroll, yeah, let me go to, okay. Let me, okay. So cost of production plus inventory, which is 0, and then cost of backlog. Okay, so this is the cost of level strategy. Now let's try the chase strategy and see if we get a lower cost. So our cost, total cost under level strategy is 7,800, roughly speaking. So for the chase strategy, I'm going to copy this here. So I'm going to copy monthly demand over here, okay? And here I have total supply, which equals total demand. Okay, so I'm good there. So do I have any inventories? No inventories, 0 inventory cost. Backlog, 0 backlog cost, okay? However, since demand increases or decreases every month, I also have to increase and decrease production. So again, I have these amounts of increase of production, these amounts of decreased production. So what is my total cost? So this is my production cost. This is the cost of increasing production over 12 months, cost of decreasing production over 12 months, no inventory cost, no backlog cost, 6,800. Okay, so now this is my chase strategy, and as you can see, it's less costly than level strategy. So far, this is my best option. However, I can try a mixture of the two. I can try a hybrid strategy. Now, to find a hybrid strategy, I need to use an optimization model. How you do that is illustrated in my videos. In your assignment, you're going to use the Excel solver. Some of you may be familiar with Excel solver, some of you may not. Don't worry, I start from scratch. So in the assignment, you're going to do level strategy, chase strategy, and hybrid strategy, and you'll choose the one that gives you the lowest total cost. So far we have talked about sales and operations planning, okay? And we have talked about aggregate production plan. So these are tactical level planning decisions, okay? So they're looking at multiple months into the future, they're looking at multiple quarters into the future, less than 2 years, okay? So here we have from the SNOP, we get the consensus forecast, okay? Forecast. And based on the consensus forecast, we come up with a production plan. And this forecast and the production plan are for finished goods, okay, and all SKUs combined, so total production. Okay. And here we're looking at monthly intervals. So you know what you're going to do in a month at the aggregate level in terms of finished goods, okay? However, you need a more detailed plan. You need a weekly and daily plan, and you need to think about individual SKUs, okay? You need to have a plan for each SKU. And in addition, you need to have a plan for raw materials, okay? So to do that, you need to use materials requirement planning. So material requirement planning takes these inputs from aggregate production plan and turns finished goods into raw materials inventories, breaks down SKUs, and instead of monthly intervals, you look at days and weeks, okay? So what happens after this is master production schedule, okay? So here, you start with aggregate production plan and you go to master production schedule. And the master production schedule still looks at finished goods, okay? However, you break up total production by each SKU, okay? So the master production schedule, excuse me, the master production schedule tells you how many finished goods you will make of each SKU and when, in terms of days or weeks, okay? So this is your plan for making finished goods of each SKU on which day and on which week. So given the master production schedule, you go to materials requirement planning, MRP, okay? So materials requirement planning. So MRP, okay, goes from here to here. MRP looks at which raw materials you need for each SKU, finished good, okay? Depending on what you produce, which raw materials do you need? Raw materials you need. And this also includes semi-finished products. I will say work in process, okay? So these are semi-finished. Okay. Depending on how much finished goods you make, which raw materials and work in process do you need, and how much? Okay. So which raw materials and how much? Okay. How much? And then it allows you to think about production, inventory, or purchasing. Okay. So you need certain raw materials, but you may already have them in inventory. If you don't have the necessary raw materials in inventory, you can make them, produce, or you can purchase them. And it gives you a plan of days and weeks. Okay. So we have started our plan, our tactical plan at this level, aggregate production plan and SNOP. And then we have made it more detailed along each SKU across days and weeks. And we have further detailed it to raw material requirements. What do you need? How much? When? Okay, do you make or purchase, or do you have it in inventory? Okay, so this and this, master production schedule and MRP, are operational planning processes, because we're looking at days and weeks, maybe even months. Okay? But these are SNOP and aggregate production plan are tactical planning processes. All right, so how does MRP work? Okay, so let's look at this. So MRP is basically a schedule, okay, that tells you what you need, when, and how much. And when we're talking about what, it refers to raw materials and work in process inventories. Okay. So the input comes from aggregate production plan, and this tells you how much you will make in total in a month. Once you know that, you can break down that single number into production quantities for each SKU. Okay, so this is a schedule of which SKU, finished goods, you're going to make in which weeks and days. Okay, so once you have this for these finished goods, for these SKUs, how much, what kind of raw materials you need and how much, okay? That comes from BOM, or Bill of Materials. Bill of Materials is a list of parts and components you need to make a single finished good item. For example, let's say you're selling egg timers. So this is your finished good, this is what you make, this is what you ship to your customers, this is what customers buy you, so this is your finished good. Now, if you want to make one egg timer, a single item, you need certain raw materials. You need ends, maybe top and bottom. You need one bulb. You need supports. Okay? For one finished good item, you need 2 ends, 1 bulb, and 3 supports. Okay? And then for this 1 bulb, you need 1 gram of sand. So as you can see, this is a list of raw materials that you need to produce a single item of finished goods. And as you can see, this is fairly simple. In real life, you will have products, SKUs, with hundreds and hundreds of raw materials in sub-assemblies. Okay? So, the bill of materials tells you what you need. Okay? Now, some of this may already be in your inventory. Okay? So then that's good. You already have what you need. But the rest has to be purchased, ordered from raw material suppliers. Okay? So you need to have a plan of what to order, how much to order, when to order. Okay? So this is how MRP works. Now, continuing with the MRP example here, this table at the top is the master production schedule. Okay? So it's about the egg timer, that's the finished good. Okay? And you have how much to make and when to make. Okay? So you're going to make, your production quantity is 1. Okay? And it's going to be, the quantity needed is 1 in period 8. Okay? So that's your schedule for egg timers. Okay? In period 8, you need to have 1. That's your master production schedule. However, there is a lead time. In this case, lead time means how long it takes to produce 1 egg timer. Lead time is 1. That means you need 1 period to make an egg timer. Okay? So if you want the egg timer finished in period 8, you must start 1 period before. Okay? Because it takes 1 period to make an egg timer. You start production in period 7, and in period 8, your egg timer will be complete and finished and ready to be shipped. Okay? So this is the master production schedule. It tells you what to produce when. Okay? However, before you can start production, you need to have a certain amount of raw materials ready. Okay? So before you can start production, you need to have a sufficient number of ends, a sufficient number of bulbs, a sufficient number of supports. Okay? So MRP starts here. Okay? This part is MRP. Okay? The top table is master production schedule. This is MRP. So to start production in period 7, you need 2 ends. Okay, ends. Okay, so your requirement, your need is 2. Okay, so first you check if you have this in inventory. However, your records tell you that you have 0 ends in your inventory. So what that means is that you need to purchase this from your suppliers, okay? And you need to have 2 ends delivered in period 7. When 2 ends are delivered in period 7, you can start production, okay? However, there's a lead time. Lead time is 5, so the duration between placing and receiving an order is 5 periods. So from period 7, I go back 5 periods. Okay? So what this tells me is that I need to place an order 5 periods ahead of time. If I want to receive 2 ends in period 7, I must place an order in period 2. Okay? So this is the quantity, this is the time, what to order, how much to order, when to order. Okay? So this is what I'm going to order from my supplier in terms of ends. Now, to make one egg timer, I also need 3 supports. Okay? So I need to have 3 supports available in period 7 so that I can start production. Okay? So first, I check my inventory. In my warehouse, I have 2 supports. That's good, but I need 1 more support. I need 1 support delivered in period 7 so that 2 in the warehouse plus 1 delivered in period 7 should give me a total of a total of 3 supports. So when should I place an order? I look at the lead time. Lead time is 1. So if I want to receive the supports in period 7, I need to order them 1 period ahead of time. So I need to order 1 support in period 6 so that I receive it in period 7, and I'll have a total of 3 supports available for production. Going on, for each egg timer, I need 1 bulb, okay, in period 7. I have 0 in inventory, so I need 1 bulb delivered in period 7. So I look at the lead time, it is 1 period. So in order to receive the bulb in period 7, I need to place an order in period 6, and so on and so forth. So this is the general idea behind materials requirement planning. Here, we're looking at days and weeks. So what are the goals of materials requirement planning? The first goal is to ensure availability of materials, raw materials, work in process components for the planned production. So master production schedule, we want to implement the master production schedule. To make the production happen, we need to have available certain raw materials, work in process inventory, sub-assemblies in appropriate quantities. Also, MRP tries to keep as little inventory as possible. Okay, so we want to have enough raw materials, but only as little as possible, only as much as we need, not more than that. Okay, so how does this work? If you look at this, here I need 2 ends delivered, right? So lead time is 5, okay? So I order 5 periods ahead of time, okay? If you think about, this is the last possible moment to place an order. Now, I could have placed an order earlier, but MRP pushes everything to the last minute. Why? Because if I order early in period 1, I will receive the, excuse me, if I order in period 1, I will receive the ends in period 6, and I would have to keep those items in inventory in my warehouse from period 6 to period 7. Okay? If I order early, I will need to keep inventory to eliminate this necessity. The MRP pushes everything to the last minute. That's how MRP tries to minimize inventories. Okay? And in addition, MRP helps you plan manufacturing activities, delivery schedules, daily, weekly deliveries, and purchasing activities. When to place an order, for which item, how much, etc. Okay. So, what are the advantages and disadvantages of MRP? Now, MRP tries to minimize or eliminate inventories. However, it also allows you to maintain a reasonable safety stock, some extra inventory on the side. MRP helps you identify process problems. Why? Because MRP forces you to look at every stage of production, which materials you need, for what product, in what quantity, when. So you go through the entire production process step by step, and it will help you to identify any issues with the production schedule. Also, MRP can help you make production schedules based on actual demand. It helps you coordinate raw material ordering. Okay? So these are some advantages of MRP. Now, some disadvantages. First disadvantage is you cannot do MRP by hand. Okay? So you need to have an ERP system or some specialized software for you to properly do MRP. So it's computer intensive. And once you make MRP work, it's difficult to make changes, because if you imagine you're making, let's say, hundreds of SKUs for which you may need thousands of raw materials. Once you establish those relationships, it may be difficult to make changes afterwards without breaking all these relationships. Now, if you do MRP, your ordering costs and transportation costs can increase. How come? Well, in MRP, you try to minimize inventories. Okay? So, if you need 2 ends, you're gonna order 2 ends. Okay? Now, the supplier may offer you a discount if you buy 3. Okay? So, if you don't need 3, MRP tells you don't take the quantity discount, get only as much as you need, even though you pay a high price for it. Okay? So MRP tells you not to, the MRP tells you to decline quantity discounts and purchase as little as you want. Also, in terms of transportation, MRP pushes everything to the last minute, so you cannot bundle different shipments. Let's say this shipment, this shipment, this shipment, so they happen at different times. You could actually combine these 2 shipments and save money, but the MRP says no. You need to have this shipment here and this shipment here, because MRP doesn't want this too early. So to reduce inventory costs, you may have to break up shipments and pay higher transportation rates. So they can become quite complex. Sometimes it doesn't work exactly as needed. So these are the basic advantages and disadvantages of MRT.